We start now next point, which is called function. So here a function is a special type of relation. So on relation, you know what is the relation. On relation, we put some conditions, so it become a function. Remember, every function is a relation. Every function is a relation. But relation need not be function every time, not always. So let me define now what is a function. So we start with two non-empty sets. So this is precise definition of a function. We start with two non-empty sets. Let A and B be two non-empty sets. That means they are not empty. So a relation. Now earlier we used capital R for relation. Now we use F for this function. So relation F, there is a symbol for function, from a set A to a set B is called a function. So this will be subset of A cross B because it's a relation. It's called a function if every member, so the word every is important, every member of A is connected, or you can say that associated with unique means exactly one. This means exactly one member of B. So here in this relation we have used two important words. One is every member of A. That means you need to take every member of the set, and that member should be connected, means associated with one and only one, that is a unique member of the set B. So such a relation is known as a function from A to B. And we write here, symbolically, we write F, then this colon symbol, we put A here, then arrow, and then this B. This is read as F is a function from A to B. I repeat, this is read as F is a function from A to B. Here A is called domain of the function. A is called domain of F, and B is called codomain. This is called codomain of the function. Codomain of F. Domain and codomain. I repeat, here F is read as function from A to B. So that first set is called the domain, and the second set is called the codomain. So this is a function F from A to B, where A is called the domain and B is called the codomain. When I say that F is a function from A to B, means it's a relation in which every member of A is connected or associated with exactly one member of the set B. So you can call it a relation or rule. You can call that as rule also. Rule or relation or mapping. F is also called rule or relation or mapping. This is also standard terminology, mapping from A to B. So when we say that F is a mapping from A to B, that means every member of the set A is connected with exactly one member of the other set. Suppose if I take one member A from here, A from A, it is connected with B, for example. Then we write symbolically like this. We write F, inside the bracket we write small a, and here we write small b. This is read as F of a equals to b. This is not into, it's not like this, remember. Inside the bracket we just put a here. This means a is connected with b, and here b is called image of a. Here b is called here image of a. So here image, that b is called image of a, and if you do reverse, the corresponding member here, a is called pre-image. A is called pre-image of b. B is called image of a, where a is called pre-image of b. So indirectly you can say that in terms of relation, here it would be which ordered pair? A comma b. You recall the relation. So a comma b belongs to, in relation we used to write r, here we write f. So a comma b will be in f. So here b is called image of a, or a is called the pre-image of b, remember. So this is the definition. I hope this is clear to you. I repeat one more time. F from a to b, this is read as function from a to b. Here a is called domain and b is called codomain. It means every member of the set A is connected with exactly one member of the set B. Then it is called a function. Remember, every relation need not be a function, but once it is a function, it has to be a relation, because on relation you are putting some conditions. A function is a special type of the relation. Let's consider the following relations. First one, relation from A to B here. Suppose I have here 3 members, 1, 2, 3. Suppose here I have 4, 6, 7, 8. And this is given to you. Suppose 1 with 6, 2 connected with 7, and let's take 3 connected with 8. So you can see that here every member of the first set is connected with exactly one member. 1 connected with how many? 6 only. 2 connected with how many? 7 only. 3 connected with how many? 8 only. So this relation is a function. Is a function from A to B, for example. So I can write f from A to B. Let me call this as a function f from A to B. Here domain is A. This is a domain, 1, 2, 3 member. Codomain has 4, 6, 7, 8 members. So as I explained, the 1 connected with 6, so I can write f of 1 equals to 6. 2 connected with 7, so I can write f of 2 equals to 7. 3 connected with 8, so I can write f of 3 equals to 8. In another language, I can say that image of 1 is 6, image of 2 is 7, and image of 3 is 8. So these 3 members comes from codomain, 6, 7, and 8, remember. There you may have extra member, which is 4, which is not connected with any member. It is quite possible. So this set of images, if I form set of images, if I form, this is called the range of the function, range of f, which is usually denoted by rf. R stands for range for function f. So what is that? It is 6, 7, 8. It is usually written as fx, f of x, where x belongs to the domain of the function. So if I take 1 from the domain, so we'll get the f of 1. What is the f of 1? 6. If I take another member from the domain, 2. What is, so this become f of 2. What is the f of 2? 7. If I take third member from the domain, that is 3. So we'll get the f of 3. What is that? 8. So it is set of images. This is nothing but the set of images. So here range of the function is 6, 7, 8. Domain is A, codomain is B, remember. Now I'll take one more example here. Let me take this one, second one. suppose one set A here, another set B here. Suppose I have here 2, 6, 7, 8. Here suppose I have A, B, C, 3 members. Suppose 2 connected with 8, 6 connected with B, 7 connected with C. Now here you can see that every member of the first set is not connected with the members of B. One member extra 8 is left here, which is not connected with any member of the domain. So this is not a function. It is of course a relation, not a function. This is not a function. Why? Because there is one member 8 which is not connected with any member of this. So not a function. You recall two important words, every and exactly one. So not a function. Third example, if I take this way for it here, suppose here I have 1, 2 and 3 members set A. Suppose here I have 6, 7, 8, 3 members. 1 connected with 6, 2 connected with 7, 3 connected with 8. Let's take 3 connected with 9. Now here every member is connected, but 2 connected with how many members? 6 and 7. That means 2 has 2 different images. So again, not a function. Not a function. Every member of this, every member should have unique image. Unique image. Then it is called a function, remember. Every and unique. Here every condition is not true. Your unique condition is not true. Every and unique. Here 2 has how many images? 2 different images. So this is not a function, remember. Now this is of course a relation. If you write here, this is a relation, this is a relation, this is a relation, but these two are not a function. This is a function. If I come back to this here, I can write the function like this also in form of ordered pairs. 1 connected with 6, so 1 comma 6. 2 connected with 7, so 2 comma 7. 3 connected with 8, so 3 comma 8. So this way also you can write function in terms of ordered pairs. This is in terms of symbol f, this is in terms of function. Both have standard ways of writing. You can use this way or this way. You can write alternatively function. This is a function in terms of ordered pair. So this is a function, remember. Now here you can say that every member has exactly one ordered pair. You look at to this. If I write here set of ordered pairs, so 1 comma 6, 2 comma 7, 2 comma 8. So 2 is connected with 2 ordered pairs, so not a function. 3 comma 9, yes, this. So this is just a relation but not a function. Not a function. So either you can write in terms of ordered pairs. There it says that every member should have exactly one ordered pair. Here you see 2 has 2 ordered pairs. That means 2 has 2 different images, 7 and 8, and therefore it is not a function. There 8 you have not used with any member, therefore this is also not a function. So either you can use this way or this way. So here range will be this 6, 7, 8. This is fx. This is nothing but what? Fx. F of 3. This is f of 2, which is 7. This is f of 1, which is 6. So 6, 7 and 8 forms the range, which is called the set of images. Range is always subset of codomain, remember, for any function. It might be equal also. It can be equal also here. That is, this is always true. RF is subset of B, codomain. Always true. It might be equal also, but in general, this is a subset of codomain. You see here range has 6, 7 and 8 members. This is a subset of B. B has 4, 6, 7 and 8 members. If I draw 4, then both will be equal. So in general, subset or equal to. Now let's take function of this type. Suppose here I have some members 1, 2, 3, 4, and here I have members, let's take 6, 7, 8 for example. Relation from A to B. Suppose 1 connected with 6, 2 connected with 7, 3 connected with 7 and 4 also connected with 7. Now the question is this relation represent a function? That's the question. So you need to check these two conditions. every and unique. These two conditions. Every member should have unique image. Unique means exactly one. So one member you pick up, you see it connected with how many members? I'll take one first. I'll pick up one. Now what do you think? One connected with how many members? So you can see that it is connected with exactly 6. Okay, so in case of one you are through. Go to 2. 2 connected with how many members? 7 alone. You can see here 2 connected with 7, 1 only. Go to 3. 3 connected with how many members? You can see that it is connected just one member, which is 7. Of course 2 and 6 both are connected with same member, but 2 connected with 1 only. 2 goes to with 1 only. It's not like that 2 goes to with 2 different members, remember. So 2 connected with 1 only, 3 connected with same member, but it is 1 only. Look at it. 3 diagram is not like this, remember. 3 goes to 7 only. What about 4? 4 again goes to 7, but that is 1 only. If I look at a diagram of 4, it is just 1. It's not like this. 4 with 2, 3, it's not like this. So here, this is also a function. So if I call this as, for example, g, small g, it's a function from a to b. What is g of 1? That is 6. What is g of 2? 7. So image of 2 is 7. What's the image of 3? Again 7. What's the image of 4? Again 7. So these 3 members, 1, 2 and 3 goes to single only. So here image of 1 is 6, image of 2 is 7, image of 3 is again 7, image of 4. These 3 members are having same image. It is quite possible. So you can say that range of the function g is 6, 7. What is the range? Set of images 6, 7 here. And it is, of course, you can notice that the subset of codomain. What is codomain here? Which is B, and which is 6, 7 and 8. You can have extra member here in codomain, but not in this. If I put 5 here, it is no more as a function. So this is a function, remember. You can write, if you want, in terms of order pair, g equals to 1 with 6, 1 ordered pair, 2 with 7, only 1 ordered pair, 3 with again 7, only 1 ordered pair, 4 with 7, only 1 ordered pair. Every member 1, 2 and 3 and 4 should have exactly 1 ordered pair. So this is another way of writing the function. 6, 7, 7 forms the range of the function. Even like this also you can write. Here I have number of members, remember. And here I have just one member. Let me take, for example, 2. Here I may have 0, -1, 2 and 3. And here all members are going with 2 only. This is also a function, remember. This is also a function. If I call this as a function h, for example, let me call this as x and this as y. So h is a function from x to y. H is a function from x to y. And here image of every member of the domain is just 1. So here you can write h of 0 equals to 2, h of -1 is also 2, h of 2 is also 2, and h of 3 is also 2, remember. So here you can say that range of function h is just a singleton set, singleton 2. But it's a function. Every member, 0 goes to how many member? 1 alone. -1 goes to how many member? 2 alone. 2 goes to how many member? 2 alone. 3 goes to how many member? 2 alone. So h is a function from x to y. Image of every member is just one member, which is 2. So this is a function. This is a function from where to where? This is a function from x to y. Here x is domain, y is codomain, and range of the function h is just a singleton 2. Let's take one more example on infinite set. Suppose this is set of natural numbers n. Here you have 1, 2, 3, 4, 5 and so on. Another set which is also infinite set. Let me take same. Again natural numbers 1, 2, 3, 4, 5, 6, 7, 8, and so on. Both are infinite sets. Now I'll give the relation in this way. Suppose 1 goes to 2, 2 connected with 4, 3 connected with 6, 4 connected with 8, 5 connected with here 10, here you have 9, and so on. So what do you think? Is this relation represent a function? So check for two conditions, every and unique. Every member should have unique image. 1 goes to 2 only, 2 goes to 4 only, 3 goes to 6 only. You are just making double here, remember. If I take 5, then it becomes 10. If I take here 100, for example, then here it becomes 200. So there's a function you can see, and it's a function from n to n, natural numbers to natural numbers. Now here f of 1 is 2. What is f of 2? You know, double. It's a rule which gives us double. What is f of 3? What's the rule? You make it double, 6. What is f of 4? You make it double. What is that? 8. What is f of, if I write 20, you will get double, which is 40. What is f of 100? It becomes double, which is 200. And so remember here, this 1, 2, 3, 4, 5. All this comes from the domain. I cannot choose f of 0. This is not correct way of doing, because 0 is not there in the domain. And this corresponding member should come from the codomain only. This is domain, this is codomain. And so now every time to write this, it's difficult task. So in general, here you can write this way. If I pick up any member x from this, then on the other side you get double of it. So I'll write 2x. So this is called the formula for the function. X is just a variable. If I pick up any number from domain, so this comes from the domain, remember always. If I pick up any member from the domain, then the corresponding number will be its double. So now this is a general formula of the function. So sometimes function is also denoted by such symbol. This is called the formula for function. Formula vary from function to function. Instead of x, you can use another variable also, like this. Or I can write, if I take number n from this, small n, then you will get the double of it, that is 2n. This you also can write, but this n comes from the domain of the function, and the corresponding value should come from the codomain. This is the image. Or you can use anything. Suppose I can use y also. So if I use y here, you would have 2y. This is not important what you are using, whether y or n. Usually we use x. So this way, if you have function from infinite set to infinite set, you can represent in this way. What is range? I think now you can predict very easily. R of f, range of the function. Set of images, 2, 4, 6. So it's even positive integers, 2, 4, 6, 8, 10, and so on. Even natural numbers. This is the range of the function. It has to be infinite. And you note that here it is a subset of codomain. Note that RF is a subset of codomain, which is natural numbers. Okay. So this way you can represent a function defined on infinite set. Let me take one more function. A function now. You know very well familiar with the function f from z to z, all integers to all integers, and defined in this way. Fx equals to x square. This is given to you, remember. Function from z to z, fx equals to x square. So every member would have unique image. And what's the image? That is its square. Here you pick up one member from the domain, then the corresponding member will be its square. This is the image. This is a given member from the domain. This comes from the domain, and this comes from the codomain. You take one number from the domain, the corresponding member will be its square, like this. If I take 0, I can take 0 because z consisting of 0, z consisting of all integers. So if I take 0, 0 square, which is 0. If I pick up 1 here, then 1 square, which is 1. You know z also consisting of negative numbers. So minus 1, then minus 1 square, it becomes 1. Here minus 1 and 1, remember, this is minus 1, this is 1 for example. Both goes to 1 and it is quite possible in a function, remember. Members should have unique image. If I take 2, then 2 square, which is 4. If I take minus 2, then minus 2 square. What's the image? 4. If I go to, for example, 3, then 3 square. What's the image? 9. If I take minus 3, what's the image of minus 3? Minus 3 square, which is 9 again, and so on. So these are the images, only this many numbers. Codomain is entire Z, remember. So if I write the range here, range of the function, if I called RF here, it would be 0, 1, 4, 9. Then next you can predict it has to be 16. Next you can predict it has to be 25, and so on. All perfect squares number. These are called perfect squares number. Next 7 square, which is 49, 81, and so on. This is infinite set. It is a subset of codomain. So this way we can understand concept of the function when it is defined on infinite set. If I take one more here, function f from real numbers to real numbers here, and let me write fx equals to for example let me write 2x plus 1, such rule. Now what is the rule here? You take any real number, remember this is not all integers, this is all real numbers, so you can have fractional value also. In this example, you cannot select f of 1 by 2 because this 1 by 2 is not in the domain. So this way you cannot do here, but here I can. So if I try for some examples, you will realize we want to just understand what the set of image is. That is our main concept in this 11th standard. We try to get the correct range in every case. That gives you more concepts of the function. So if I take 0 for example, then 2 into 0 plus 1, 2 into 0 plus 1, so which gives us 1. If I take 1 here, then 2 into 1 plus 1, so we'll get 3 here. If I take 1 by 2, I can take 1 by 2. Any number, remember, real numbers means all numbers. So 2 into 1 by 2 plus 1. So this gives you 2. If I take, for example, minus 1 by 2, then 2 into minus 1 by 2 plus 1. So this gives us minus 1 plus 1, so 0. Next, if I take, for example, let's take 1 by 4. You can take anything. So 2 into 1 by 4 plus 1. So this is 1 by 2 plus 1, so 3 by 2. If I take minus 1 by 4 here, then 2 into minus 1 by 4 plus 1. So this is minus 1 by 2 plus 1, so which is 1 by 2. If I take minus 2 for example, then minus 4 plus 1, which is minus 3. If I take 2 for example, then it will be 4 plus 1, which is 5. If I take root 2, which is a rational number, so 2 root 2 plus 1, which is a rational number. So what did you notice from image is, you see there you will getting just perfect squares number 0, 1, 4, 9. What about here? You just notice images 1, 3, odd numbers, even number, 0, fractional number, negative number. If I take for example f of minus 5, then you have minus 10 plus 1, which is minus 9. So again negative number. This is a rational number, here negative number, here you have 0, here a fractional value. So what you are thinking, what is this? 0, positive integers, negative integers, irrational number, fractional number. So what is this? Can you predict? So range here RF would be any set which consisting of fractional, positive integers, negative integers, irrational numbers. You know that it is nothing but R, so range will be R, all real numbers. So you'll get every number, whichever number you think, you will get here on this side. Here on the right hand side you are getting just perfect integers, perfect squares integer I mean. You never get 8 here. Either it is 1, 4, 9 and so on. You never find 8 here. There is no number whose square is 8. You never find 11 here. There is no number whose square is 11. So these are called perfect squares number. Whereas you look at to this, here you will get the every number, positive integers, fractional values, negative integer, 0. So you can say that this is R. Whichever number you think. Suppose if you want here, let me take 99, then you can get one number whose image is 99. Think, this is not difficult task for you. Which number gives you image equals to 99? Every number you think, you will get one number whose image is that number. So here range is all real numbers. Every number will be there on the right hand side.